Fact fool once looked up and found a swan made of stars, and so begins our quiet journey through a constellation that has guided storytellers, sailors, and scientists alike. When night settles over the mid-latitudes, Cygnus stretches across the sky like a silver river bird in flight. Its wings span the Milky Way, its beak pointing toward the bright star Deneb. Even to those who don't know its name, the pattern feels familiar. Something about it suggests motion, grace, and quiet strength. Long before telescopes and antennas, people imagined the swan gliding among the heavens. Greek poets saw Zeus disguised as one. Chinese astronomers spoke of a celestial bridge of lovers meeting once a year across the Milky Way. In the north, storytellers pictured migrating birds carrying the seasons with them. Each tale tried to make sense of a shape that seemed to shimmer with intention. As the earth spins, Cygnus wheels overhead in summer and early autumn. If you stand on a dark hill and follow its neck toward Deneb, you trace one of the vertices of the Great Summer Triangle. To the west shines Vega, to the south Altair. Together they form a celestial landmark, a triangle drawn across humid July nights. Within that frame, the Milky Way brightens into a milky ribbon, so thick it seems almost touchable. Somewhere within that haze lies the heart of Cygnus, a region bursting with star-forming clouds. Through binoculars, the wings reveal knots of light, little cocoons where hydrogen clouds collapse into new suns. You might even sense the faint glimmer of the North America nebula, its outline resembling the continent viewed from orbit. Yet for centuries, all of this remained invisible to the naked eye, folded inside the silver mist. Still, ancient watchers felt its pull. They used Deneb to mark calendars, to time harvests, to know when river floods would come. In desert regions, its appearance at dusk meant cooler nights ahead. On seafaring maps, its arc aligned with navigation lines drawn in ink and salt. The stories and the sciences shared one language then, the sky itself. Time passed, and telescopes replaced tales. But even glass lenses could only show so much. The deeper truth of Cygnus waited in a wavelength no human eye could see. It waited for radio waves, the long, invisible murmurs of the cosmos. In the early 20th century, a few curious engineers noticed static on their antennas that didn't come from storms or cities. That static had rhythm. It drifted with the stars. When Carl Jansky rotated his antenna in the 1930s, he realized the hiss grew loudest when the Milky Way rose. The universe, it turned out, was speaking in radio. From that discovery came a new kind of astronomy, one that didn't rely on light, but on soundless signals. And among its favorite subjects was Cygnus, because tucked inside that graceful bird lay something extraordinary, one of the brightest radio sources in the entire sky. Scientists named it Cygnus A. To the eye, it's nothing, but through radio telescopes, it blazes like a bonfire a billion light years away. Two immense lobes of energy extend from a tiny core, each streaming jets of particles nearly the speed of light. Today we know that core hides a supermassive black hole inside a distant galaxy. Yet when the first maps appeared, no one knew what could scream so loudly across the cosmos. Imagine the mid-century observers at places like Joudrell Bank or Green Bank. Giant dishes pointing toward the constellation, turning slowly through night air that smelled of dew and iron. The signal appeared as a faint rising curve on long rolls of chart paper, a pencil tracing that pulsed with something unimaginably vast. They followed it, line by line, until an entire new universe began to take shape. Soon more voices emerged from Cygnus, There was Cygnus X-1, discovered in the 1960s, an X-ray beacon so intense it seemed impossible. It flickered as if something were devouring light itself. Years later, astronomers realized they were witnessing a black hole consuming a nearby star. For the first time, humanity had real evidence that such monsters existed not just in equations, but in the living sky. It's humbling to think this all happens within the same outline that ancient eyes traced as a swan. What was once myth became data. What was once story became spectrum. Yet both ways of seeing still belong to us. The lore and the logic, two wings of the same bird. If you've ever stood beneath a clear mid-latitude sky, you know how gentle the transition feels. The air cools, cicadas fade, and above the treetops the Milky Way arches like a luminous river. Cygnus crosses it at right angles, diving southward toward the horizon. Even without knowing its history, something about it stirs a quiet sense of direction. It points the way as if reminding us where the center of things might be. Tonight we travel along that path, from lore to astrophysics, from visible to invisible. We listen to the universe, not with ears but with understanding. We trace how radio astronomy transformed our picture of space. And maybe, by the end, we glimpse how wonder survives every translation. The first section of our voyage begins close to Earth, in those mid-latitude observatories where the sky rolls like a wheel overhead. Here, instruments sit among meadows and pine forests, far from city lights. Their parabolic dishes gleam in moonlight, patient as open palms, each one tuned to a whisper billions of years old. At night, operators check dials under red lamps. A printer chatters softly, feeding out long ribbons of data. The noise is gentle, constant, hypnotic. Every few minutes, the signal drifts as the Earth turns, bringing a different part of the sky into view. When Cygnus climbs high, the meters twitch, and the quiet hiss turns into music. These observatories don't chase spectacle. They listen. And what they hear reveals the hidden architecture of galaxies. Through radio, dust clouds become transparent, jets become measurable, and magnetic fields draw invisible maps across the void. From this vantage, the Milky Way looks less like a band of light and more like a vast lattice of hydrogen. Every frequency tells a different story. Some trace star formation, others outline relics of supernovae. By tuning between them, astronomers reconstruct the history of matter itself. Cygnus A, that distant powerhouse, taught us that galaxies can live dual lives, quiet in visible light, yet roaring in radio. The energy comes from gravity itself, matter spiraling into darkness and flaring outward in jets that span hundreds of thousands of light years. In some frequencies, those lobes appear like ghostly wings, echoes of the swan reborn in physics. Closer to home lies the Cygnus Loop, the remains of a supernova that exploded thousands of years ago. To the eye, it is faint filaments of gas curling in delicate arcs. But through radio maps it reveals a shell expanding through interstellar space, its shockwaves still sculpting new nebulae. It is the grave of a star, but also the cradle of the next generation, because every atom in your body, carbon, oxygen, iron, once passed through such fire. The more we listened, the more the universe spoke. Cygnus became not a single object, but a realm, a corridor of discoveries that bridged folklore and modern science. Each new signal drew us further from myth, yet closer to meaning. Think of Deneb again. It as one of the brightest and farthest naked eye stars, roughly 2,600 light years away. Its light left before the rise of ancient Greece, before writing reached most of the world. When you see it tonight, you're rewatching a message that began before history itself. Through radio, we learn that Deneb is a massive blue-white giant, fusing hydrogen at furious rates. One day it will end in a supernova, perhaps leaving behind another expanding loop. And thus the cycle continues. Around Deneb swirl countless smaller suns, young clusters wrapped in dust. Radio wavelengths slip through that dust, revealing nurseries invisible in optical light. Here, astronomers study how gravity competes with turbulence, how magnetic threads guide collapse. Each observation refines our models, but it also revives an old intuition that creation is never silent. Back on Earth, the people who operate these instruments know their work can feel monastic. Days of calibration, nights of listening, they watch weather forecasts as much as the stars. A gust of wind can tilt a dish. A passing plane can ruin an hour of data. Yet in that patience there is peace, because somewhere between the static, a pattern emerges, and with it understanding. In mid-latitude summers, when humidity rises and frogs call from ponds, the faint hiss of the universe still trickles into their headphones. They drink coffee, note timestamps, and smile when Cygnus passes meridian. For a moment, they feel part of something ancient, a continuation of those who once watched the same stars for signs of gods or weather. If you could stand beside them, you might not see much. Just a metal dish turning slowly under a sky thick with stars. But if you closed your eyes, you'd sense how the air hums with history. The whispers of quasars, pulsars, and remnants of first explosions, all blending into one gentle sea of noise. Inside that sea hides a secret. Order. The radio spectrum isn't chaos, its structure woven into soundless frequencies. From the 21-centimeter line of neutral hydrogen to the pulsating millisecond bursts of neutron stars, every note carries a clue. And Cygnus, sitting astride the Milky Way, plays a symphony of them. Sometimes the signals arrive irregularly, bursts that last mere milliseconds. Astronomers debate whether they remagnetars, collapsing fields, or something else entirely. Each new detection sparks theories, some elegant, some wild. But that's the charm of radio astronomy. It leaves room for wonder, for possibility. The instruments that make this possible are feats of quiet engineering. Take the Very Large Array in New Mexico. Though not always aimed at Cygnus, its design echoes those first mid-latitude observatories. Dozens of dishes spread across desert plains, moving in concert. Together they simulate a telescope kilometers wide, resolving cosmic details finer than any single mirror could. When those dishes align on Cygnus A or Cygnus X-1, they paint radio pictures of jets curling like smoke, of magnetic fields spiraling outward. Yet despite the sophistication, the principle remains humble, listening, interpreting patterns, translating energy into understanding. It's the same instinct that made our ancestors link bright points into a swan. Perhaps that's the deeper continuity. Every era hears the sky through its own instruments, story, lens, or signal. But the yearning beneath never changes, to know where we are, to belong in something vast. As dawn nears, Cygnus tilts westward. The first birds on Earth begin to stir as the bird of stars sinks. In that mirror, myth meets morning. The constellations fade, but their echoes remain in memory, in equations, in the hum recorded on magnetic tape. We follow those echoes further, from these quiet observatories to the cosmic engines that power them, because within Cygnus lies a chain of insight that connects radio waves to relativity itself, a path from gentle hiss to the deep roar of space-time. And that's where our next chapter begins. The story of Cygnus grows louder as we tune deeper into its signals. Each frequency reveals another layer, a quiet ladder from myth to mechanism. By the middle of the 20th century, the world's attention had turned skyward in a new way, not with telescopes alone, but with antennas spread like petals across continents. At Cambridge, at Green Bank, at Parkes in Australia, a generation of radio astronomers learned to hear what had been invisible for all of human history: the hiss of hydrogen mapping the spiral arms of our own galaxy, the low throb of quasars from billions of light years away, and somewhere between them, the steady pulse of stars that refused to die quietly. That's where Cygnus began to change our understanding once again. In the late 1960s, an X-ray source, Cygnus X-1, puzzled every observer who measured it. The energy output was far too great for an ordinary star, yet no visible counterpart could be found. Satellites picked up flares that seemed to vanish into silence. Something was feeding, unseen, on its companion. Theories spread like wildfire. Some claimed it was a neutron star, others a new kind of collapsed object. It wasn't until the 1970s that data confirmed what once sounded like fantasy. Cygnus X-1 was the first strong evidence for a black hole, an object so dense that not even light could escape its gravity. And so, within the Swan, humanity encountered the first tangible proof of a cosmic abyss. Imagine that moment. Physicists poring over readouts in fluorescent, lit rooms, realizing that the mathematics of relativity had just stepped off the page into reality. An unseen star, invisible yet voracious, pulling matter into a whirlpool of space and time, the very curvature of space-time twisting, heating gas until it glowed in X-rays. Every photon screamed as it circled the drain of creation, but the story doesn't end with gravity. Because Cygnus became more than a testbed for equations, it became a reminder that beauty and violence coexist among the stars, that even destruction can give birth to understanding. Those who work in radio astronomy often speak of listening rather than seeing. When you listen long enough, you begin to recognize personalities in the cosmos. Cygnus roars, a steady, powerful tone across frequencies. Cygnus X-1 flickers, a restless, unpredictable heartbeat. Elsewhere in the constellation, pulsars tick like cosmic clocks, spinning remnants of exploded suns. Their beams sweep across Earth with perfect regularity, each rotation marking the passage of seconds in a rhythm older than civilization. One of those pulsars, nestled near the Cygnus constellation, became a beacon for mapping the structure of the Milky Way. By timing its signals, astronomers measured distances and discovered that the galaxy's magnetic fields are far more intricate than we once imagined. Lines of invisible force threading through interstellar clouds, guiding cosmic rays and shaping how new stars form. These are not abstractions. They fingerprints of creation, etched in radio waves that drift endlessly through the dark. When you look up at Cygnus, you see the visible tip of something vast. Behind the glowing wings lies the Cygnus arm, one of the great spiral arms of our Milky Way. It stretches through regions thick with gas and dust, regions that radio telescopes cut through with ease. By mapping hydrogen emissions at 1.42 gigahertz, the famous 21 centimeter line, astronomers traced the swirling structure of our galaxy. Emitted when hydrogen atoms flipped their spins became a cosmic signature. It showed us where the stars are born, how the spiral arms curve, and where we are among them. The mid-latitudes turned out to be perfect for such listening. Not too close to the equator, where humidity muffles signals, not too far north where auroras hum with interference. From these calm belts of Earth, dishes scanned Cygnus as it climbed the southern sky each night. The data flowed by the gigabyte, but the essence remained the same: patience, precision, and quiet awe. Think of an engineer in the 1970s, sitting alone in a control van beside a great white dish. He adjusts the azimuth by hand, the motors whir softly, and on his oscilloscope, a faint squiggle steadies. Outside, crickets call. Overhead, the swan crosses the Milky Way, its wings shimmering in starlight. He takes a breath, knowing he's hearing the voice of a black hole, a signal that began before humankind even learned to write. Such moments repeat in every generation. Today, vast interferometers link antennas across continents, combining signals with atomic clock precision, yet the principle is the same. Listen, record, understand. Through those instruments, Cygnus became a reference point, a laboratory for almost every branch of high-energy astrophysics. When scientists test new theories of jets, plasma, or relativity, they turn to Cygnus A and Cygnus X -1. When they study how galaxies evolve, they compare radio lobes, counting their symmetry, their brightness, their polarization. Each measurement whispers a clue about cosmic engines hidden in darkness. And still, amid the data, the old stories breathe. The swan, the bird of light, the traveler between worlds. For centuries, it symbolized transformation. Now it embodies it more literally than ever. A myth reborn as a model of space-time itself. To look up and see not only stars but the deep machinery behind them, it's strangely calming. Because the more we learn, the more connected it all becomes. Every radio pulse, every particle jet, every nebular glow, they all verses in one continuous song. The Milky Way hums at many octaves. Low radio waves from hydrogen clouds, microwave echoes from the Big Bang, infrared warmth from dust, optical light from stars, X-rays and gamma rays from violent births and deaths. Together they weave the spectrum of existence, and Cygnus is one of its loudest singers. Astronomers often translate radio data into colors to make sense of it. Bright blues for high frequencies, reds for lower ones. When they map Cygnus A this way, it looks almost alive. Two fiery wings stretching from a glowing heart. The resemblance to a bird isn't lost on anyone. Nature seems to echo our imagination, or maybe it's the other way around. At the center of Cygnus lies a galaxy, not unlike our own, except its black hole is billions of times more massive. Matter spirals inward, heating until it emits radio waves strong enough to cross the universe. Those jets travel hundreds of thousands of light years, compressing intergalactic gas and lighting up new regions like cosmic lanterns. It's an act of creation born from destruction, gravity transforming collapse into light. And yet, if you step back, it is also quiet. The signals that reach Earth are unimaginably faint. A whisper buried under the noise of our own technology that SY observatories hide in remote valleys, shielded from cell towers and power lines. In that silence, the universe speaks more clearly. Back in the mid-latitudes, night falls again. The dishes tilt upward, following the swan as it glides overhead. Somewhere a notebook lies open, filled with columns of times and frequencies. Each entry a breadcrumb on the trail from curiosity to comprehension. You could say that Cygnus is the teacher of humility. It reminds us how little we truly see with our eyes alone. That most of the cosmos lives beyond our narrow band of perception. And that sometimes, to understand, we must first learn to listen. But Cygnus also teaches patience, because its stories unfold across centuries, even millennia. A single burst of radio might take eons to travel here, and we, brief as we are, catch only a passing note. Still, we record it. We build archives so future generations can listen again, perhaps with sharper instruments. Someday, they might find in our static a new discovery we missed. That's how science endures, as a long conversation across time. When I think of Cygnus, I think of the way human history reflects it. The earliest cave markings of constellations, the sailors steering by Deneb, the monks copying star charts under candlelight, the engineers wiring vast arrays in remote deserts, all tracing the same pattern across different centuries, all searching for meaning in the same stretch of sky. Even today, space agencies send signals outward, hoping to be heard. Those transmissions pass through Cygnus on their way to nowhere and everywhere. For a brief moment, our human voice mingles with the natural chorus of quasars and pulsars. It is a humbling thought that our entire civilization is just another note in that grand harmony. The radio waves we emit from satellites, from broadcast towers, from every phone and radar, spread outward at light speed. In a few thousand years, our electromagnetic echo will pass through the Cygnus region. Perhaps some distant intelligence orbiting a star near Deneb will detect a faint pulse and wonder who sent it. They may build myths around us, just as we once built myths around them. In that sense, the sky is not only a map, but a mirror. Each generation projects itself upon it. For us, Cygnus became the bridge between poetry and physics, between the swan of lore and the black hole of reality, between wonder and understanding. If you close your eyes now, imagine drifting above Earth in the stillness of orbit. Below, the continents fade under night. Above, the Milky Way spills like frost across the darkness. Cygnus arcs over your window, a glowing cross against infinite black. Every star, every pulse, every photon whispering the same message. There is more to see, more to feel, and in that whisper you realize the universe is not cold. It's alive with memory. Every wavelength a story, every frequency a voice. We only just learning the language. Soon we'll follow that language even deeper, tracing the evolution of radio astronomy itself. How it grew from backyard antennas to global networks, from curiosity to precision. How the swan became a symbol not just of myth, but of method. And how, through it all, the human heart kept pace with the hum of the stars. That's where we go next, into the age of arrays and orbits, where Cygnus becomes both subject and teacher of an entire science. By the time the world entered the digital age, radio astronomy had become an orchestra of precision, no longer a single dish listening in solitude, but entire networks linking their ears across the planet. This technique, called interferometry, stitched signals together using the rhythm of atomic clocks. It allowed scientists to see with the sharpness of a telescope the size of Earth itself. And when they turned this immense ear toward Cygnus, they began to see the structure of the unseen. At the heart of these efforts stood observatories, like the Very Large Array in New Mexico, Effelsberg in Germany, and the GMRT in India. Each dish, though thousands of kilometers apart, listened to the same cosmic whisper, recording signals onto precise time-coded tapes. Later, computers combined them into one coherent picture. It was like listening to a distant orchestra by gathering every note from every corner of the world. The result was breathtaking. Cygnus resolved into twin jets stretching like fiery tendrils of plasma. Each lobe expanded tens of thousands of light years from its core, where a black hole, 1 billion times the mass of the Sunday, spun in darkness. The jets themselves emitted radio waves as electrons spiraled around magnetic fields at nearly the speed of light. Every turn of those electrons sang across the void. What once looked like an empty patch of sky became one of the brightest beacons in the radio universe. Yet, amid that grandeur, the small and humble still mattered. In quieter corners of Cygnus, researchers found molecular clouds, nurseries of stars. The Cygnus X region near Denham became a treasure map for those studying stellar birth. There, massive clouds of hydrogen and carbon monoxide clumped together under gravity. Slow pull. Within them, dust absorbed visible light, hiding the process from optical telescopes. But in radio wavelength, the scene unfolded like an ultrasound of the galaxy. Womb. From these clouds emerged clusters of young stars, bright, hot, and short-lived. Their radiation carved bubbles through the gas, sculpting intricate arcs that mirrored the wings of the swan. Astronomers mapped each contour, calculating densities and temperatures, unraveling how stars ignite from chaos. It was as if Cygnus were teaching us both ends of creation, the explosive deaths of giants and the quiet births of their successors. In the mid-latitudes, where observatories dot rolling hills and temperate fields, this research thrives. Cool nights, moderate climates, and clear horizons provide stable conditions for sensitive receivers. When the constellation rises high, its signals pass almost directly overhead, minimizing atmospheric distortion. And so, the mid-latitudes became the natural home for listening to Cygnus' story. From the plains of North America to the valleys of Europe and the steppes of Asia, dishes followed its path in synchronized arcs across the sky. There's something deeply human about this choreography. Dozens of teams across continents, connected not by sight, but by trust in time, each recording its tiny slice of the cosmos, knowing that when combined, those fragments form a masterpiece. It's cooperation at a scale that mirrors the very fabric of the universe, many parts, one pattern. Inside control rooms, scientists speak in quiet tones. They discuss calibration, polarization, angles, baseline lengths. Yet outside, the night feels timeless. Sometimes when the data streams clean and steady, someone steps out for air. They tilt their head back, find Deneb, and for a moment remember why all of this began. Not for fame or fortune, but for that ancient urge to understand the light above us. Through radio astronomy, Cygnus became more than a constellation. It became a laboratory for testing relativity, plasma physics, and the behavior of matter under extreme gravity. Each discovery in its realm rippled outward, reshaping cosmology itself. When we understood Cygnus A, we understood galaxies. When we measured Cygnus X -1, we understood black holes. And when we mapped its star, forming clouds, we understood our own beginnings. But the magic of Cygnus isn't T only in what it reveals. It S in how it humbles us. For every question answered, another appears just beyond reach. Why do some galaxies launch jets while others remain silent? What controls the spin and feeding of black holes? How does the invisible magnetic architecture of the universe shape the birth of stars? These mysteries whisper from within the swan swings, beckoning us onward. In the late 20th century, radio astronomy expanded into space. Satellites like the Russian Radioastron orbited Earth, extending interferometry beyond the planet itself. The longer the baseline, the sharper the image. By pairing a space antenna with ground-based arrays, scientists created a virtual telescope the size of 500,000 kilometers. They pointed it at Cygnus, refining our view of its jets down to light, years across. For the first time, humanity was truly listening from both Earth and sky. Meanwhile, new generations of receivers grew more sensitive, more agile. Cryogenic cooling reduced noise to nearly nothing. Digital correlators processed signals in real time. Where once it took days to combine data, now it took seconds. The universe began to unfold at human pace. And yet, for all the technology, the act of listening remained poetic. The instruments changed, but the wonder didn't. We still wait for the faint rise of the signal, still feel that pulse of discovery when the data resolves into meaning. It's the same awe our ancestors must have felt when they traced a swan among the stars with nothing but their eyes. There is a quiet symmetry in that. The constellation that once guided travelers across seas now guides scientists across dimensions. Its shape is a map, its light a clue, its silence a challenge. Every generation adds another layer, from folklore to optics to radio to gravitational waves. Each one a new way of hearing the same song. And what a song it is! Even the silence between frequencies speaks. The background hiss, the so-called cosmic microwave background, washes through Cygnus just as it does through every part of the sky. That faint afterglow from the birth of the universe mingles with the newer voices of stars and black holes, all layered together in a single continuous harmony. The oldest light meets the newest, and the swan glides between them. When you think of it that way, Cygnus is like a time machine. Look at its bright stars, and you see light that left before civilization. Listen in radio, and you hear signals that began when the first galaxies were young. Each frequency is a different moment in cosmic history arriving at once. To gaze at Cygnus is to see billions of years stacked in a single field of view. No myth could have imagined a story so vast. But myth, in its own way, prepared us. It gave us language to describe wonder before we had equations. It kept curiosity alive until instruments could catch up. And even now, when we speak of wings or hearts or jets, we still borrow poetry to explain precision. Perhaps that's the real fusion, science sustained by story. In one sense, Cygnus has become our mirror. The swan's flight echoes our own search for meaning. We rise from ignorance, glide through understanding, then dive again into mystery. Each orbit of discovery feels like a graceful arc through time. There is a legend that says the swan sings one final, perfect song before it dies. A swan song, they called it. Maybe that is what we rehearing through radio waves, the song of dying stars, of collapsing galaxies. of matter transforming into light. One last time yet in that song lies renewal. From the ashes of supernovae come new worlds, new listeners, new stories. The universe never ends. It simply changes key. When astronomers point their dishes at Cygnus today, they do so not just for data, but for continuity. Every scan adds to decades of accumulated knowledge. Old recordings are compared with new ones to track slow changes, a jet widening, a pulsar drifting, a nebula expanding. It is a kind of cosmic diary written across generations. Each line says, "We were here, we listened, we cared to understand." At night, far from cities, if you lie beneath a clear sky, you might trace Cygnus crossing the Milky Way. Follow its wings until you reach Deneb at the tail and Alberio at the beak, a golden blue double star shimmering like twin lanterns. To the eye, they blend into one gentle point. Through a telescope, they reveal duality. Two lights orbiting one another, bound yet distinct. It is a fitting symbol for all we've learned. Unity and diversity, simplicity and complexity, always intertwined. Sometimes in long exposure photographs, the Milky Way behind Cygnus glows so vividly it resembles a river of milk. That's why ancient people called it that, but through radio we now know it as not milk but hydrogen, the most abundant element in the universe. The same substance that fuels stars, fills interstellar space, and lingers in every molecule of our bodies. We are, quite literally, made of the same song we listen to. In that realization lies something profound. Every signal from Cygnus passes through us, through our planet, through the iron in our blood. We are participants, not observers. The universe is not out there, it's within us. Each wave that brushes our antennas also brushes our skin, our oceans, our hearts. We are the instruments, tuned by curiosity, resonating with creation. The more we understand that, the gentler the cosmos feels. Not hostile, not indifferent, simply vast and alive, moving in rhythms too large for a single lifetime. And when we finally step away from the data and look up, we see that the old stories and the new equations are not opposites. They are translations of the same truth. The swan has always been singing. We've just learned to hear more of its song. Now, as we drift toward the final part of our journey, we follow that song beyond science. We listen to what Cygnus tells us about ourselves, about time, wonder, and the quiet courage to keep asking questions, even when the answers vanish into static. Because in the end, that's what it means to be human under the stars. If you've followed this far, you've traveled through centuries of wonder, from the first storytellers tracing a swan in the sky, to the modern scientists mapping jets of plasma billions of light years away. You've crossed the bridge from myth to mathematics, from whispering folklore to radio waves older than our world. And still, Cygnus glides on, unchanged, serene, eternal. Every night, it rises again above the mid-latitudes, the same graceful wings spanning the Milky Way. You could set your clock by its appearance. Ancient farmers once did, sailors once did, and in a quieter sense, scientists still do. Each observation a marker of time, not the hours of a day, but the long pulse of human curiosity. There's a certain comfort in that repetition, a reminder that even as our tools evolve, our longing stays the same. We look up, we listen, we learn. The rhythm continues, steady as the turning earth beneath us. Some nights, The signals from Cygnus reach us delayed by storms or solar flares. A hiss in the data, a skip in the rhythm. But even then, the universe never truly stops speaking. Its voice might fade, but it returns patient and ancient, like tidewater finding the shore again. If you imagine standing beside one of those great radio dishes now, you hear only the wind, maybe the faint click of relays, the soft hum of motors keeping perfect alignment. Above you, the stars shimmer, but the real action is in silence, invisible waves passing through everything, through metal, through you, each one carrying a memory from a corner of creation. 1 billion years ago, a black hole in Cygnus launched twin jets into space. Those waves have traveled all that time, crossing intergalactic emptiness to brush the edge of our atmosphere. Now they recaught by human hands, transformed into numbers, then into meaning. It, such a fragile thing, knowledge carried on ripples of nothing, and yet it survives, it endures, because we choose to listen. That's what sets our species apart. We listen for what we cannot see. We give voice to silence. We turn static into story. Cygnus taught us that, from the myths of divine swans to the measurements of radio galaxies, it showed that imagination and observation are not enemies. They are partners in understanding. The lore once said the swan ferried souls between worlds. In a sense, it still does. Every signal from Cygnus carries not just cosmic truth, but a reflection of us, our patience, our curiosity, our willingness to find harmony in the unknown. Each wavelength a bridge between what we dream and what we prove. When night deepens and the world grows still, Cygnus becomes a teacher of silence, not the kind that's empty, but the kind that's full of potential, full of listening. The same silence that fills an observatory control room when a discovery begins to take shape. The hush before the realization. The moment when the universe and the human mind meet halfway. If you've ever been awake at that hour, when air cools and the stars seem to draw closer, you'll know the feeling. A gentle awareness that we live inside something vast and alive. The radio waves pass through you, though you can feel them. The light of Deneb falls on your skin, though it left its source long before you were born. And suddenly, everything feels connected, every breath, every story, all part of the same grand current moving through time. Sometimes when people first hear of black holes or quasars, they imagine violence, collapse, destruction, chaos. But listen closely and you'll hear something else. Grace. Even in the most extreme events their S-order, their S-rhythm, matter falls. Energy rises, cycles renew. It as a dance as old as gravity itself. And Cygnus, with its swan shape, reminds us that even the fiercest forces can take the form of beauty. Far away in radio images, the twin lobes of Cygnus stretch outward like wings. Between them glows a dark heart, invisible yet central to everything. Isn't that always how it is? In life too, the unseen centers hold the most power. Gravity binds galaxies. Love binds people, both invisible, both real. Through every age, we looked upward for meaning. We built myths when we needed comfort, equations when we needed proof. But the truth is, both spring from the same well, a longing to belong in something greater than ourselves. And when we listen to Cygnus, we hear that belonging echo back, not in words, but in waves. The universe saying softly, "You are part of this." Each time the swan crosses the sky, it carries that message. The same one whispered to shepherds, sailors, scientists, dreamers. That wonder is not a luxury. It is our nature. To look, to question, to be moved by what we don't yet understand. That is how we grow. That is how we stay human in a universe of stars. Now picture the earth turning once more. The dishes fold downward as dawn approaches. Screens fade to static. The operators stretch, drink the last of their coffee, and step outside. The first light of morning softens the landscape. Mist curls over the grass, and above the horizon, Cygnus drifts toward daylight, wings dissolving in blue. It leaves behind its whisper in the receivers, its reflection in our minds. For a moment, the world feels perfectly balanced. Sky and soil, myth and math, past and future, all part of one continuous breath. The hum of the universe, still faintly audible beneath the waking birds. A reminder that discovery is not an event, but a state of listening. That wonder doesn't end when the sun rises, it just changes form. So tonight, when you find yourself beneath a quiet sky, look for the cross of the swan. Follow its neck down to Deneb, trace its wings across the river of the Milky Way, and know that within those stars lies everything we ever sought: mystery, memory, and meaning. You relooking at stories written in light older than history itself. You rehearing in your own way the faint hum of eternity. And if the night is calm, you might even sense the echo of our instruments listening back. Humanity scattered across continents, united by one shared act: the courage to be curious, the will to keep asking, the patience to hear the universe answer in its own time. So rest now. Let the story of Cygnus linger with you. The swan glides through the Milky Way, and somewhere a radio dish turns its face to the stars. The signal hums softly, steady as a heartbeat, endless as time. We are part of that rhythm. We always have been. Good night.